Now we have the castle problem on the review. This is just basically a little launched object problem. The two equations at hand here are the distance equation, telling you how far a thrown or launched object will go. That's when you know the velocity of it, and you know the angle at which it was launched. Sometimes you're given the distance that you want it to go, and you find the time. Sometimes you're given the time that it's in the air, and you find the distance. You go either way with that. All right? What we're going to do in this problem, we know that the object was launched from a height of 20 feet. It's trying to go 150 feet. If you didn't see that in your packet, please add that in. It needs to go a distance of 150 feet. The angle is 47 degrees. The speed is 60 feet per second. Is it going to make it over this wall? Okay? If you were able to put these two equations in and you graphed it, you might look at my little curve that I made there and agree with it. I don't think it's going to come anywhere close to going over the wall. All right? In fact, its maximum height reached only comes out to be about 50 feet. It's going to fall well short of the wall that it's trying to go over. Here are the two equations that you should be using. Velocity, angle. Velocity, angle. Included with the y equation, which is height, is the gravity portion of it, negative 16t squared. And the initial height, think of that as like a starting boost that it got. It was released from a height of 20 feet off the ground. To do this problem, what I decided to do, there are multiple ways you could do this, I said, well, how long will it take, what will the time be, for it to reach the castle 150 feet away? So I put 150 in for x, and I solved for t. When you do this, when you divide by these two things, make sure you divide with parentheses around the whole thing. The time came out to be about, what was it, 3.7 seconds? Okay, we'll round to the nearest tenth just for simplicity. So what we do then is we plug that time, 3.7, in for these two t's to see how high it is at that time, how high off the ground. That height, y, I think comes out to be negative. Times the sine of 47 plus 20. When you plug that time into this equation, what does the y come out to be? If it's negative anything, that height means it's underground. Would it be over an 80-foot wall? No. The object fell well short of its goal.